question concerns the proper terminology for conductors running from a pole-mounted service transformer's fuse disconnect switch to a panel board or automatic transfer switch, specifically whether they should be classified as service entrance conductors, service laterals, or feeders. To clarify this, let's define each term according to the National Electrical Code, or NEC. Service conductors are the conductors from the service point to the service disconnecting means. The service point is defined as the point of connection between the serving utility and the premises wiring. Service entrance conductors are the conductors between the service point and the service disconnecting means. Service laterals are underground service conductors between the street main, including any risers at a pole or other structure, or from transformers, and the first point of connection to the service entrance conductors in a terminal box, meter, or other enclosure inside or outside the building wall. Feeders are all circuit conductors between the service equipment, the source of a separately derived system or other power supply source, and the final branch circuit over current device. In the scenario described, the service is not metered and is the user's own power. The key is to determine where the service point is considered to be. Since the transformer is pole-mounted and fused on the high side with a fuse disconnect switch at the bottom of the pole, the connection to the serving utility would most likely be at the top of the pole or at the transformer itself. The conductors from the transformer to the fuse disconnect at the base of the pole are, in fact, service conductors. Now the question is, what are the conductors from the fuse disconnect to the panel board or automatic transfer switch? Because the transformer is user-owned and the service is not metered, one could argue that the service point is at the transformer itself. If this is the case, the conductors from the transformer to the fuse disconnect would be service conductors, and the conductors from the disconnect to the panel board would then be feeders. However, if the utility considers the service point to be at the connection point on the pole, then the conductors from that point to the fuse disconnect switch would be service conductors, and the conductors from the disconnect switch to the panel board or automatic transfer switch would be service entrance conductors. The length of the run, whether it's 100 feet or more in underground, does not solely determine the classification. The presence of the fuse disconnect switch at the base of the pole is also a critical factor. If this disconnect switch is considered the service disconnecting means, as it appears to be, then the conductors from the service point to this disconnect are service conductors. The NEC defines service equipment as the necessary equipment, usually consisting of a circuit breaker or switch and fuses, and its accessories connected to the load end of service conductors to a building or other structure, and intended to constitute the main control and cutoff of the supply. In this case, the fuse disconnect switch fits this definition. In the provided description, the grounding configuration within the fuse disconnect switch is significant. The service transformer neutral grounding electrode conductor, equipment ground conductor, and neutral conductor to the panel board are all bonded to the case, and the grounding electrode conductor goes to the grounding electrode. This is a typical service equipment grounding arrangement. Considering the above, the conductors from the fuse disconnect switch to the panel board or automatic transfer switch are most accurately described as service entrance conductors if the service point is at the utility connection on the pole. If the service point is deemed to be at the transformer itself, then these conductors would be feeders. However, given the typical configuration of a pole-mounted transformer and disconnect, it is more likely that the conductors are service entrance conductors. It's important to consult with the local utility and the authority having jurisdiction to confirm the exact location of the service point. This will definitively determine whether the conductors in question are service entrance conductors or feeders. Here's a breakdown of the NEC articles that apply. Firstly, NEC Article 100 defines the term service conductors, service entrance conductors, service lateral, service point, and feeder. Secondly, NEC Article 230 covers service conductors and equipment. Thirdly, NEC Article 250 covers grounding and bonding. The NEC defines service entrance conductors as the overhead or underground conductors between the service point and the service disconnecting means. Service laterals are defined as underground service conductors between the street main, including any rises at a pole or other structure or from transformers, and the first point of connection to the service entrance conductors in a terminal box, meter, or other enclosure, inside or outside the building wall. Feeders are defined as all circuit conductors between the service equipment, the source of a separately derived system, or other power supply source, and the final branch circuit overcurrent device. Considering the definitions and the provided scenario, the conductors from the fuse disconnect switch to the panel board or automatic transfer switch are most likely service entrance conductors. However, the determining factor is the location of the service point. If the service point is at the utility connection on the pole, then these conductors are service entrance conductors. If the service point is at the transformer, then these conductors are feeders. Consulting with the local utility and the authority having jurisdiction is essential to clarify the service point location and ensure compliance with local codes and regulations. Also, to further clarify, consider these additional points. The purpose of the disconnect switch is to provide a means of disconnecting the service conductors from the building or structure. This disconnect is typically located at an accessible point, such as the base of the pole. The conductors from the disconnect to the panel board or automatic transfer switch are therefore considered service entrance conductors. The length of the run is not a determining factor in the classification of these conductors. Whether the run is 100 feet or more, the conductors are still service entrance conductors if they connect the service disconnecting means to the panel board or automatic transfer switch. The grounding configuration is also important. The service transformer neutral, grounding electrode conductor, equipment ground conductor, and neutral conductor to the panel board are all bonded to the case of the disconnect switch. This is a typical service equipment grounding arrangement and further supports the classification of the conductors from the disconnect to the panel board as service entrance conductors. In summary, the conductors from the fuse disconnect switch to the panel board or automatic transfer switch are most accurately described as service entrance conductors. The determining factor is the location of the service point, which should be confirmed with the local utility and the authority having jurisdiction. This ensures compliance with the NEC and local codes and regulations. Think of it this way: firstly, service conductors bring power from the utility to the service point. Secondly, service entrance conductors connect the service point to the service disconnecting means. Thirdly, feeders distribute power from the service disconnecting means to the final branch circuits. The location of the service point is the most critical factor in determining the correct terminology. In the given scenario, the fuse disconnect switch acts as the service disconnecting means. Therefore, the conductors from the service point, typically the utility connection on a pole, to the fuse disconnect switch are service conductors, and the conductors from the fuse disconnect switch to the panel board or automatic transfer switch are service entrance conductors. If the service point were the transformer, then the conductors from the transformer to the fuse disconnect would be service conductors, and the conductors from the disconnect to the panel board would be feeders. Remember, consulting with the local utility and the authority having jurisdiction is crucial to confirm the exact location of the service point and ensure proper classification of the conductors. This will help avoid any confusion or disagreements among the engineering staff and ensure compliance with all applicable codes and regulations. Also, the NEC provides clear definitions and requirements for service conductors, service entrance conductors, and feeders. Understanding these definitions is essential for proper electrical system design and installation. Here are some additional details to consider to make sure there is no confusion. The role of the grounding electrode conductor is to connect the service equipment to a grounding electrode, such as a ground rod or water pipe. This provides a path for fault current to return to the source and helps to protect against electrical shock. The equipment ground conductor provides a path for fault current to return to the source from equipment enclosures and other metal parts. This also helps to protect against electrical shock. The neutral conductor carries the unbalanced current in a three-phase system. In a properly grounded system, the neutral conductor is bonded to the grounding electrode conductor at the service equipment. This bonding ensures that the neutral conductor is at or near ground potential. The NEC requires that the service equipment be properly grounded and bonded to provide a safe and effective electrical system. This includes the proper installation of the grounding electrode conductor, equipment ground conductor, and neutral conductor. In the given scenario, the grounding configuration within the fuse disconnect switch appears to be correct. The service transformer neutral, grounding electrode conductor, equipment ground conductor, and neutral conductor to the panel board are all bonded to the case, and the grounding electrode conductor goes to the grounding electrode. This is a typical service equipment grounding arrangement and helps to ensure the safety and reliability of the electrical system. Finally, always refer to the latest edition of the NEC and any applicable local codes and regulations when designing and installing electrical systems. This will help to ensure that the system is safe, reliable, and compliant with all applicable requirements. This explanation should provide a clear understanding of the differences between service entrance conductors, service laterals, and feeders, and help to resolve any disagreements among the engineering staff.